my name is Anton. Thanks for introduction. Yeah, we are from Chain Security, and we are famous for doing audits. This is all our awesome clients that we have to work. Had pleasure to work with, and we are started in 2017. So we have a good long history of doing security audits, right? And we are now developing a tool, we already did before, that would try to, again, solidify all our knowledge in something that would be runnable over different code bases and can be reliable. You can think of what we do want to do is automated checklist, right? That is a default pipeline for developers to use, and of course there is now interest in such things as bot races in Code Arena, right? Where people competing to write bots that detect things, and we believe maybe extending our tool may be a good option for these developers. And in general, my talk is not going to be only about the tool. It's more will be about the techniques and things you need to kind of care about when doing static analysis, right? What's important and what we believe for Solidity analysis is important. You can see here Solidity because our tool targets Solidity, right? So to start, let's think about look at high-level overview of what is analysis, right? So here we usually have a smart contract. Smart contract is a piece of code that somehow transitions the state of smart contracts from one state to another, right? And in general, you can describe this state as some cloud, right? Cloud of states that you're gonna have, right? And some states in this contract might be considered by developer invalid, right? Here I say might be considered by developer because if there is no specification, if developer says that anything is okay, then you technically don't have bugs, right? The notion of bugs comes from developers putting some effort, putting some notion into the smart contracts, right? And let's see how you can test for the bugs, right? One way and most popular and should be default to go for many developers is regular testing, right? It's a technique that allows you to write a test that tests certain behavior of a smart contract. You maybe want to multiply two values, or maybe sum up two values, right? We all know, I hope, at this point, how to write the tests as developers, right? And this pretty much works, but the problem, it only reports you the issues that you have tested, right? And you can miss things just because you haven't had a test, right? You hadn't had a test for this particular property, let's say, for this particular case of a property, right? None of these techniques here can protect you from incomplete or wrong specification, right? It's only if you have a unreachable, in reality, state of full specification, you can say that you're strong, right? But testing can be done better way. It's symbolic analysis, right? Where instead of using concrete numbers, you are using symbols, right? You're gonna have a higher coverage doing this testing. Only you see on this cloud, we're gonna cover parts, blocks that are much bigger than the test space. And this, of course, can report more violations, but as well it can miss, right? And static analysis or verification, they can report you false alarms, but ideally you're not missing violations if your property is good enough, right? So this is our motivation for static analysis, why it's perfect match for automated checklist. It's because worst case, you're gonna have false positives that you need to filter, right? Okay, so speaking about timeline, we had history of doing tools before. These first two tools, Securify and Securify 2.0, they were research prototypes that we did a while ago when we were a startup from Federal Institute of Switzerland. And now we are doing it slow, steady, but it's not a research anymore. We are trying to implement this project Cypher, right? The target Solidity. We only rely now that we're going to analyze the Solidity version 8, right? Writing it in Rust, it brings us speed, and just because a bunch of Solidity, oh, not Solidity, Ethereum tooling is written in Rust, we are actually relying on some external dependencies to do this, right? It's like a lot of people writing in Rust for smart contracts, right? What is static analysis? Let's dive into the terminology, right? It's process of inspecting the state without executing it, right? You inspect the cloud of your states without executing it. You want to identify bugs. You want to identify security vulnerabilities. In reality, even compilers doing static analysis themselves for some kind of constant folding or other things. And usually it's done by automated tools. So now the question, what is automated tool, right? What can be it? And for that, let's go to first example. This is, maybe you know, famous contract, multi-call, used by a bunch of contracts. And there is a well-known problem with this contract. You don't need to read the code, I'm going to explain it. It's basically message value is unreliable in any other contract that is extending this functionality, right? Just because there is delegate code inside the loop. If you do it in a loop, you're gonna have a bad time, let's say. So if any other function of your contract has a message value in it, right? And one way how you can detect it, it's, for example, how it's done by FOAnalyzer, right? For Codarene's FOAnalyzer. This is a legit approach. This is technically already a static analysis. You are not executing code, but you are reasoning about it statically, right? You see, it's just a regex. Still works, but there is going to be some false negatives even, assuming that delegate call happens not in the body of a function, but in some other function that body calls, right? But this is still already a legit approach, and it could find bugs, right? Next approach, and this is how you can make it more extendable, is internal representations, right? I have an example here of the Slither. It's the same exact multi-call, right? Intermediate representation brings you a bunch of benefits, such as code becomes much more easier to work with. Syntactic sugar going to be removed, right? Code, you can see, for example, control flow structure will be incorporated inside the IR, right? This is quite a standard for almost all IRs. This is much nicer to work with, and because it's a graph, right? You can use the graph algorithms at this point, right? You don't have to write hard to understand for non-regex people regexes, right? You can just define graph algorithms that's easier to understand, right? And about desugaring, for example, you have seen there's two loops I have in this contract, right? And they both will be compiled to exactly this kind of abstracted IR, right? We are not going to have any difference between while and for loop when we do it this way, right? Okay, and we are in our tool will be using IR as well, right? It's quite similar to actually Slither, and the like Hamilton's kind of IRs. Just much nicer to work with than with bare AST or bare code regexes, right? And for the next thing, I want to speak about the precision of analysis. This is something that saves time of humans, right? Like machines are really good at patterns, but to save the time of humans, this needs to be precise, right? You don't want to deal with a lot of false positives. And for that, let's look at this example. It's quite standard violation in the software weakness library, I think. It's called direct compare, like unexpected ether balance, right? So if you see here, you have strict equality with balance, but there are multiple ways how you can force ether in a smart contracts, right? One of them is a self-destruct opcode. So this check will be unreliable in real world. You ideally need to use greater or equal, right, or something. But let's, with this simple pattern that strict equality with balance is bad, take a look at what can be done for analyzing with precision, right? And one thing is called flow sensitivity, right? It's a flow sensitive analysis considers the sequence of operations, right? So we have two functions, one called true positive. This is something that we want to detect. And there we're storing the balance to variable A, and then we're strictly comparing it, right? So we want to report this comparison as a bug, right? Another is false positives, where we're storing balance to A, but afterwards we're overriding A, and strict comparison in this case will not be a problem anymore, right? But to reason about this, you need to have something called flow-sensitive analysis, right? It's quite standard, I think, in all analysis. Slither does it as well. They're using like a single static assignment for it. We're going to use other technique I'm going to mention later, but this is already really important for precision that helps you save your time afterwards, right? Another saving technique is field sensitivity, right? This is, we know in Solidity there is a lot of structs, right? This is this data type that allows you to put a bunch of variables in one variable, right? And it is actually on analysis level already quite hard to distinguish between different field of structs, right? You need to exactly have analysis that is field sensitive to be able to distinguish this bug, right? So what's the bugs there? Pretty much like the same. We are storing, but this time to the field of our data struct and comparing. Another time we're storing it to the A, but comparing B strictly with some number, right? And in the second case, it's not a bug because the field will be different, right? And distinguishing between these two cases is actually on analysis level, it's really quite hard. Like you need to do special field-sensitive analysis to do it, right? Next one is object sensitivity. Pretty much the same, but you see here we're gonna have two data variables. One is data, another is another data, right? And conditionally, you're gonna create a link. You're gonna create basically pointer from one data to other data, right? And if you need to distinguish between what your current data pointer points to, this gets even harder because pointer analysis is complicated. You need to maintain proper domains to do this. But this is what we believe something is needed for Solidity, right? Objects since ABI v2 start to be default almost everywhere. You can use them in a call data. You can use them as arguments and everywhere, right? So it's quite mandatory at this point already to distinguish between two different objects, right? And third, sensitivity we believe is very important is something called call context sensitivity, right? For example, here is this ID functions that just returns the value you pass to it. And in one case, in one function, it's used, and then it strictly compares A, which is actually X, with a strict number, but it could be potentially tainted by call done by a completely other function with the balance, right? And if you don't distinguish that only that particular call to ID X is not tainted, but you consider that everything is like, once you have input to the function and it can be a block timestamp and the output it can be also block timestamp, then it's distinguishing between different outputs of the same function call is not that simple, right? Okay, so this is 4 things that we believe important for static analysis. Let's see now how we're doing it, right? And this is, we're going to think to more like topic called more like scientific or abstract interpretation, right? It's pretty close to, let's say, symbolic execution, but we're going to highlight some difference. And actually, easiest to highlight it is some example. So here we're going to have a function foo. It takes two arguments, a and b. It assigns some value k, local variable k, and there's two branches in a if conditions that differently mutate the state. Like, you don't need to look much there, just for example. But on the right-hand side, you see kind of CFG or IR of that code, right? And let's take a look how would we concretely test it first, right? If we were to test concretely, we would pass some values a and b to the function. The execution will be deterministic, so we're going to take some branch. In this case, it will be the left branch of this CFG, right? And in the result, we'll get some end state, right? You don't need to follow it. It's just more or less to show you what will be the actual execution model rate of it, right? And difference will be doing a sort of more or less called symbolic execution, where we start with symbols, where we don't know what's A, we don't know what's a B, but we're executing. And interesting part comes when we are dealing with branching, right? In our case, to save the effort of computation, our condition doesn't enforce anything on A, right? A stays as anything, even if we know that it's zero technically, right? This is where abstraction comes in abstract execution, right? We don't fully collect all the constraints. And once we split on a condition, we don't know which branch to take, right? Because we are not evaluating conditions, so we need to take both branches. When taking both branches, there is two different things we can do. We can either continue each execution thread separately, but then you're running up in a problem where your state space explodes, right? Because imagine on each condition you're gonna double your state space, right? It grows exponentially, it's not good. So standard approach in the abstract interpretation is to merge your states, right? And yeah, I want to highlight the only interesting variable in this merging. It's where m in the left-hand side is anything, on the right-hand side is 0, right? By merging, we are basically saying, okay, after execution of this if condition, we're merging two states and creating a state where m can be anything, right? With this, we can continue, but you see, for example, the k value was 2 in the left-hand side, 2 in the right-hand side, so we're not gonna abstract anything, we're gonna preserve the information about the variable k, right? So this was the domain of, let's say, is very concrete or it's anything, but with domains you can do way more interesting things. And one interesting example is, for example, decimal domain. So this is based on the real bug. Like I was trying to find an example, and it was a real bug where problems arise due to how decimals worked, right? Who are not familiar on this loop, it's where you should be looking at. So we are getting some token from the predefined list of tokens. We are querying its balance, and then you see when we are assigning the variable n, this is normalization to the internal precision of decimals, right? This is where we are multiplying to the power, and power is distance to the decimals of tokens, right? So on a CFG, you see there, we can actually detect and say that it's just called normalized operation, right? Sanitization, sort of, right? And the only interesting part in this case, it's only like a loop body, and executing loop body will yield you something like that. So we start with initial balance, and we assume that it is normalized. It's actually, I'm skipping how you can like deduce that the balance is normalized, right? Because it's actually quite hard already. But good assumption to assume that everything is normalized in this case, right? And then when you see the line where we are reading the B, the token balance of this, right? You can assume we are returning unnormalized value, right? So any query of the balance of will be unnormalized. And only after we are passing that n is normalized of b, we assume that n is normalized, right? By executing this loop, once we actually can terminate it already, because we're not going to learn any new information by executing this loop second time, right? It's what so-called fixed point in this abstract interpretation. And by the end of execution, you know that balance will be normalized as before. So what the actual bug was in this code is that if you see this second function balance that tries to sum up the balance of this, which is normalized as we learned from the execution, and you see there we're trying to actually query balance of again, and we, as we speak before, assume that balance of returns unnormalized value. This is where the problem comes, because you actually need to sanitize this balance of as well, right? This was found, I think, in Code Arena. I just cherry-picked one of the issues that highlighted nice the property. And just this was an example to demonstrate how domains can be quite manipulated to prove the property you want to prove, right? Okay. Another thing that we are really have thought of and think really good improves the precision and the utility of the static analysis tool is the so-called bundle. So if you know, smart contracts all are independent, right? Like you deploy them separately, but they're working together, and you cannot say that Uniswap system is just a pool. In reality, it's actually a router starts the execution, then there is also pools are deployed using the factory, right? All these contracts you know about, all these contracts you're working with, this is what we call a bundle, right? And the representation of the bundle looks something like that, right? This is where basically we have two contracts, right? But if we're having a calls between contracts, we know exactly what function we are calling, so we can, you see in the middle, connect them by the exact edges in our control flow graph, in our IR, all right? Internal calls, as you see, will be also on the left side, direct connection. This helps, I think this is quite standard, and because it's same contract approach, most of the tools are doing it the same way. And on the very right side, you see something, a call, as it doesn't lead to any entry point, right? This is what we call out of the bundle, right? In most cases, this is a call to the contract you don't know, or maybe you have annotated yourself, or like it was automatically deduced to be a call to the code that you don't control or you don't want to have any assumptions about, right? In this case, we consider this is the actual external call that can re-enter, that can be problems. But the call that you see in the middle, the one that is internal, that calls the one contract A calls contract B, sort of, right? It's not going to be considered a re-entrancy if there is no bad pattern happen, right? This re-entrancy is a problem that appears again and again, and there is now even like read-only re-entrancies that makes even harder the reasoning. And the benefits of bundle are what we believe are following. First, it's re-entrancy patterns becoming more precise, right? You're not gonna have false positives in cases when you consider that state variable was modified after call to the contract that you assume part of your bundle, right? Because you might see that it's actually compliant with you, right? Right now, I think all the tools like assume that any call is already bad, right? Any call to even the contracts that you know about and you know that it's not re-entrant is bad, right? Well, in reality, re-entrant calls are only such that somehow allow user to allow third party, untrusted party to overtake the execution, right? To like inject their code in the execution trace, right? But not all calls are like that, right? In many cases, you might be calling a token, but a predefined token like USDC that you know about, and you're not gonna, you cannot have a reentrant code there, right? Another thing is the read-only reentrancy. It's becomes, if you're familiar with the balancer V2 problem with read-only reentrancy, much harder to detect if it's multi-contract. In balancer, for example, balances are tracked by the vault, but the token supply is tracked by each pool, right? And the problem arises that if you divide balances by total supply, you need to query the data from two different contracts, right? And this is basically read-only reentrancy, not on the level of a single contract where some two variables can be manipulated wrong way. It's reentrancy on a bundle level, right? Because there's these two variables that are problematic. They are living not in one contract, but in two different contracts, right? So these properties, they can be reasoning not only about a single contract, they can be reasoning about multiple contracts, right? This is for way people writing smart contracts, like we had audited a lot of them, right? It's almost never a single contract you're getting as a scope, right? It's almost always some system, some registries, tokens, adapters to work with third-party protocols, right? And so on. So it's important to capture interactions between all these contracts that you have, right? Like, a good question will be why we are relying on the Solidity and not on the EVM bytecode. It's actually because when we are doing the audits, we see a lot of problems come from the fact that people are having like integrational problems. They, for example, calling our token, but they don't check the balance, how much they have received afterwards, right? And if you know ours, there is like this off by one error that you can potentially have on your balance just because the internal array mass was like rounding down the balance you have received, right? So to express such properties, we need to be working on the source code level. Like on the bytecode level, you're going to have too much abstraction. And yeah, third and last thing, it's holistic reasoning about smart contract systems. Exactly, you can like have independent component that build up something harder to reason about, something that behaves in a different way, right, than the separate components of the system, right? This is where the power of DeFi comes from, right? This is integration of one system with another, but the resulting behavior can be hard to analyze, and we believe the bundle will be a nice addition to work with that. Yep, I think I'm done, and I don't know, can we do questions, or? Yeah, we can do one question if somebody has.
Do you plan to release this publicly open source, and like what's the timeline on that?
So we started working in the beginning of this year. Yes, we plan to do it open source, just because tools don't sell in Web3, and we already had history. Yes, we are working on it. We plan to open source once we kind of stop building too much stuff that breaks things. We already built the core analysis, we built the IR, and we are now on the stage of building the patterns, right? Like, you cannot release this analysis framework without patterns for people to work with. But yeah, we plan it to be public good, how do you say it? Yes, okay, thank you.